Right, we're going to start the next topic, folks, which is called to do with circles. We're going to look at arcs and sectors of a circle. So previous knowledge of a circle should be that we know how to find the area and circumference. I'm just going to remind you a couple of things. So here is the circle. This is the centre. If I draw a line from the centre to the outside, that is called your radius. If I draw a line that goes directly from one end to the other through the centre, that is called diameter. Now, easy way to remember it, diameter is the long word. So it's the longer length and it makes your circle into a kind of capital D shape. Radius is the shorter word, so the shorter length. We need to be 100% clear of them because the formulas we're going to use talk about radius and diameter. Now, a new word to us is going to be a sector. Now, a sector of a circle, I want you just to think like your pizza slice. If you have a slice of pizza, that is a sector. So here is a drawing of a sector of a circle. And I'm going to call this bit AB, and this little bit in the centre is O for your centre, although it doesn't look too centred on mine. So this bit here is a sector. This bit here is a sector as well. But we need to be able to distinguish the difference between the two. This one, the smaller slice, the one with the smaller angle, is called a minor sector. And this bit here, the bigger angle, the Pac-Man shape bit, is called a major sector. Now, I think that should be quite easy to try and remember because minor is a small thing, major is a big thing. So sometimes you'll be presented with a question like this and it'll just ask you for the minor area or the minor arc length or the major. So please remember if they want minor, small, major, big, and that's what I need you to take from here. So this bit here is called a sector, and what we're going to be looking at today is how to find the arc length of a sector. The arc length of a sector is, let's go back to that pizza. If I wanted to know the length of that it's a pizza crust, that would be your arc length. So arc length is given by this formula. So arc equals the angle at the middle of the sector over 360 times pi d. Now, pi d, we should hopefully recognise, is the formula for circumference. C equals pi d gives you the total circumference of a circle. We only have part of a circle, so the angle over 360 denotes the fraction of that circle. Now, this formula is never given to you. It's one that we have to memorise. Okay? And I'm just going to go straight into some examples. So here is my circle here. I'm going to tell you that this little sector has an angle of 80 in it. And this is going to be A and B. And this is the middle. I want you to find the length of the minor arc. So this is how it's kind of presented in the textbook. So we are after the length of the minor arc. So we are after this bit here, the crust of your pizza. Please remember that. So that is what we're actually after, that length there, if I was to put a bit of string around it. So we're going to go straight to the formula. I'm not going to necessarily write it out again because I've just got it up there. So our arc equals your angle at the middle, so that is going to be 80 over 360 times pi times, now D is your diameter. Now I've forgotten to give you this in the picture, silly me. That bit there is 5 centimetres. Now that bit there is from the centre to the outside, so that is your radius. Our formula wants diameter. Now if your radius is 5, diameter is the full width of the circle, so your diameter would be 10. Now going to your calculator, there's several ways to put this in. If you guys are confident with your fraction button, that's the one that looks like this. You could just press your fraction button, you put the 80 over 360 there. Or the way I just put it in for quickness is I just type in 80 divided by 360 times pi times 10. Now to access your pi button, it is down the very bottom row and you'll have to press shift to get to it. I can't remember exactly what it's above. If you're using your phone, there should be a pi button when you turn your phone horizontal. So we're typing in 80 divided by 360 times pi times 10. And this should give you a big long answer. I'm going to round to 2 decimal places for all of these examples here. Unless otherwise told, you can do 1 or 2 decimal places as long as you round correctly. So the arc length of this particular minor sector is 6.98 centimetres. Hopefully that's okay. Right, let's do a second example. So example 2, I've got a circle again. This small angle in here is 30 degrees. And this bit here is 6 centimetres. Hopefully you can see that okay. But this time I want the major arc. So the major arc is wanting the crust of the big bit of pizza, this bit around here. Now, the formula was angle over 360, so our arc equals, now your angle isn't 30 because that's the minor bit, we want the major bit, so my question is what's that angle there? We know a full circle is 360, so take away the 30 we've given, we're looking for the big angle, so that would be 330 we're using, over 360, times pi, times your diameter again is a full distance, radius is 6, diameter is 12. Again, punch that into your calculator, 330 divided by 360, times your pi button, times 12, and this should give us 34.56 centimetres, again to 2 decimal places. Now, while I'm here, I'm going to add an extra bit to this question because there might be one towards the end of the exercise. What if the question asked for the perimeter of the major sector? Okay, cast your minds back, right the way back to first year. Perimeter of the major sector would have been the total distance from start to finish around this shape. So we've worked out that bit there is your 34.56. To get back to where we started, we have to add on that radius plus that radius. So if a question asks you for the perimeter of a sector, which is quite common, you would say your perimeter is the arc plus your radius again. So effectively we're just adding 12 onto that, which gives us 46.56 centimetres. Okay, so perimeter is slightly different because it goes from start to finish. Now these questions are also cropping up all the time in non-calculator exam papers. So although there's none in the book without a calculator, I'm going to show you one without a calculator just so you know how to do it. So this time we have a major sector, or what I call a Pac-Man size sector. I'm going to tell you that this angle here is 240 degrees and this length here is 30 centimetres. So my arc length will be, there's no mention of major or minor here because it is just the sector I've drawn. I've not drawn you the complete circle. So the arc is angle over 360, so 240 over 360 times, now pi in a non-calculator test will always tell you to take pi as 3.14. So we're doing 240 divided by 360 times pi times your diameter. So your diameter is double 30, which is 60. So first step is just what we've been doing, but we don't have a calculator here. So this is where we have to practice our non-calculator skills. Step 1 is simplify that fraction. 240 over 360, well that's just the same as 24 over 36. You should all spot that that's your 12 times table. So that is the same as 2/3 times 3.14 times 60. Okay, now what you do not ever do is do about 4 sums here. If we don't times it by 2, times it by 60 divided by 3, there is still something that's going to simplify, and it's these two things here. You will always be able to simplify this fraction with the number at the end. We can find 2/3 of 60. 2/3 of 60 is 60 divided by 3 is 20, times 2 is 40. So your sum really becomes 40 times 3.14. Now to multiply any number by 40, we're doing these since first year. You multiply this by 10 and times it by 4. So the real sum is 31.4 times 4. If I do this at the side, 4 4s are 16, 4 1s are 4 plus 1 is 5, 4 3s are 12. So the answer is 125.6. So 125.6 centimetres is my answer for that. So this is just basic sector or arc length of a sector. The exercise in the book should follow those kind of examples. As I said, there won't be a non-calculator one. but just to show you in case you put in your notes. So please remember, copy these examples into your notes and then go try the relevant page, which I will have listed on the top of this post. Just to remind though, it will be page 126 of the textbook. Next lesson will be the exact same, but we'll now be looking at the area of a sector, and it is just a slight wee tweak on the end here to our formula. So good luck, and remember, message if there's any problems with this at all.